So I'm really glad to welcome the speakers of today's seminar. Not only that one of them is our former colleague, and the other one is, well, the other one is a kind of colleague who introduced us to the French, I don't know how to say, discourse specialists, can I say? And the third one is not present, so I don't need to introduce him. And so that's one reason. The other reason is the topic, because if you read carefully the description of that talk, I think we really can expect and look forward to what will be said and during this seminar. So welcome across the river. And please, I don't know who starts. One of you. Okay.
Good afternoon. Thank you for coming, and thank you for your invitation. So Professor Hajičová and Magda to this great series of seminars. It's really a pleasure and an honor for us. Well, as the talk, and I hope that you will not be disappointed. So after the introduction by Professor Hajičová. Well, as the title indicates, our aim today is to introduce our research into syntactic complexity, both from cross-linguistic and genre variation perspectives, based on a large multilingual corpus. So my name is Olga Nádvorníková, and
my name is Alexandr Rosen, and Jiří Milička. We are really sorry that he's not here, and you will be sorry too if you ask a question and we are not able to answer that. So maybe we'll just postpone the answer for a few days. Yeah, okay. So that's it. Yeah. Oh, so what you will. What you can expect, yeah. So some introduction, then what is syntactic complexity? That's not a simple topic. So you will hear from the girls are pink, the boys are blue. Yeah. So the boys are just me, and then something about data and methods, then results. That's the main part, and you see that we switch also here. And then conclusions, that will be mainly Olga's topic. Yeah, look, you don't need it.
So what's syntactic complexity and why is it interesting? Well, syntactic complexity can be defined in general terms, in terms of general system complexity, as the number and variety of elements and the elaborateness of their interrelational structure. So there are 3 points, 3 aspects, and we will come back to them repeatedly during the presentation. So the number and variety of elements and their hierarchical or interrelational structure. Well, let's start with an example. This is an example of a cross-linguistic variation in syntactic complexity. You have here a sentence in French, source language, from the novel by Albert Camus, La Peste, and it's English and Czech translations with UD trees so from our corpus. You can see that in French we have 2 finite coordinate clauses. In syntactic complexity research called T-unit. So T-unit is main clause, including all the subordinate clauses belonging to it. And then we have 3 non-finite subordinate clauses embedded one to another. If you don't speak French, just believe me. In English, we can see that the English translator decided to split the original sentence in 2. So he joined the first part of the sentence to the preceding sentence, and then there is the remaining sentence where we have 3 finite coordinate clauses and 1 subordinate non-finite clause. And in Czech, we have 5 coordinate clauses altogether. So these differences can be quantified in terms of syntactic complexity metrics, not only the word count, but also, for example, subordination ratio, which is calculated as the number of T units, you remember T units, plus number of subordinate clauses divided by number of T units. So in French, we have two, sorry, this is, yeah, that should be point. So 2 T units plus 3 subordinate clauses divided by 2, which is so 2.5. In English, we have, so in the remaining sentence, we have 1.3, and in Czech, the flat structure, so 1 subordination ratio. In terms of interrelational structure, so the depth of this syntactic structure, we have maximum tree depth. So in French, it's 3, so 3 levels of embedding. In English, it's only 1, and in Czech, 0, so this is completely flat. What's important to say here, so I don't say that it works always like this in translations between English, French, and Czech, but there are clear cross-linguistic differences in syntactic complexity between these languages. However, recent research has shown, but not only recent research, but the research has shown in register variation and textual genre variation that there are also important intralinguistic differences between the different textual genres. This is due to stylistic preferences and traditions associated with specific textual genres, for example, fiction and registers, for example, spoken and written, but also it's due to functional and communicative needs of language users. For example, here you have 3 sentences, all of them containing the word cat, but from 3 different textual genres: subtitles, fiction, and acquis. So subtitles close to spoken language, though there are different functional and communicative needs of users than in acquis, so legal texts. And again, the differences between these 3 sentences can be quantified using syntactic complexity metrics. So you know already subordination ratio, so the lowest in subtitles and the highest in fiction, and also the maximum tree depth highest in fiction. So the clausal complexity is the highest in fiction in this sentence. By contrast, in acquis, so in legal texts, there is a high NP complexity, so 5 for maximum NP depth and 15 for maximum NP length. So a high NP complexity and also high MDD, which means mean dependency distance, and we will come back to it a little bit later. Again, I don't say that it works always like this between these 3 textual genres, but there are clear differences between the different textual genres that have to be taken into account. And we will deal with this. So in our research, we will present today. Well, but before we introduce our research, it's important to put the syntactic complexity research in a broader context. First of all, there is a huge literature, so many studies dealing with syntactic complexity in applied linguistics, so in readability and also language acquisition and language proficiency assessment, which is understandable because teachers needed to know, so what are the different syntactic complexity developments at the different levels of learners. Nevertheless, there are also, otherwise there are many studies both in diachronic and synchronic perspectives, and also in monolingual studies, in translation studies, but also in other domains. In our research, we focus on these 4 domains, so contrastive studies, register variation, typology, and computational linguistics, and well, not really NLP, but a little bit computational linguistics. But in these 2 domains, in fact, the research into syntactic complexity has been recently boosted by the advent of tree banks, so corpora annotated in universal dependencies. However, some researchers in these domains, so computational linguistics and typology as well, so they point out explicitly that their results may be biased, so skewed by the genre composition of the tree banks they compare. So if they have a tree bank, so mostly composed of subtitles, for one language, and so a mix of fiction subtitles and Wikipedia for another language. So the results may be skewed by this. And this problem is mostly due to the unavailability of large corpora, large tree banks, or large corpora containing both a large number of languages and covering a wide variety of genres. And from this point, we have a solution, hopefully, and the solution is called InterCorp, so a large multilingual corpus covering both a large number of languages and covering various textual genres. In this research, we address two main research questions. First of all, so how do syntactic complexity metrics correlate with each other? And how do these correlation patterns differ across languages and across genres? So whether there are differences. And the second research question, so which metrics are more predictive of genre and which are more predictive of language? So again, whether there are differences. It's also important to point out that this talk is based first on a talk we presented at the annual International Conference of Association for Linguistic Typologies in Singapore 2 years already ago, and yeah, a little bit, and also on a paper to appear in Linguistics Vanguard this year. Well, framing syntactic complexity. This is still pink, so this is still me. Yes, so definition of syntactic complexity, as we have already said, so in general terms, it can be defined as the number and variety of elements and the elaborateness of the interrelational structure. And interestingly, so one of the most influential definitions of syntactic complexity in linguistics, in fact, reflects mostly this general definition. So Karen Beeman says syntactic complexity in language is related to the number, type, and depth of embedding in a text or in a sentence. So syntactic complexity in a sentence can be determined by the number and type of syntactic elements, but also by their hierarchy within the sentence. And it's also important to mention that any research into syntactic complexity, I'm sorry to say that, is a simplification. And there are two main approaches to the research into syntactic complexity, the so-called relative or subjective cognitive complexity, which is related mostly to readability or difficulty of a text. And it's measuring processing load, and it's mostly reader-oriented. By contrast, the absolute or structural complexity, so it focuses on measurable linguistic features, but also they're in two completely different approaches. First, the so-called grammatical or system complexity. So for example, complexity of morphology of a given language or given languages. But the other approach, and this is our approach, so usage-based or text complexity, which measures syntactic complexity, so actually the language use, so syntactic complexity metrics in texts. So this is our approach, so the approach we adopted in this research. So far, in the literature, there are really dozens of syntactic complexity metrics. For example, in a meta-study by Tagaya and al., so in 2020, so they made a list of 47 different metrics proposed in studies during the last 30 years. So it was 130 studies, so 47 different metrics. Also in a web-based tool called linguistic profiling, you can find 100 items, mostly related to syntax. And finally, so in the first shared task on measuring linguistic complexity, so the authors used 8 morphological and 7 different syntactic complexity metrics. So there's a huge variety of metrics. We can then share the presentation if you want. However, in our research, we had to respect some important constraints while choosing the different syntactic complexity metrics, because they had to be implementable as annotation in the InterCorp multilingual corpus. So it was not an ad hoc study, so only for ourselves, but these were permanent syntactic complexity metrics implemented in the corpus. Then it had to be transparent also for future users of the corpus, not necessarily a specialist in syntactic complexity. And it had to be also reliable or applicable across many different languages, because in InterCorp you have 62 different languages, from them 49 annotated in UD, so it had to be something reliable, so across languages. And finally, it had to be computable on raw data, for example, on sentence length, so word count, but also on UD annotation. So no manual annotation or something like this. So these are the constraints, and Sasha will explain you how we or they proceeded.
Thank you. So very briefly about the corpus, we now have a version dated 2 years ago, and it's with UD annotation and with the complexity matrix annotation. You can find more details at the link. This year, hopefully before summer, we will have more text, and again, it will be annotated by complexity matrix and UD. We now have 62 languages, including 49 which are equipped with this UD annotation. For syntax, we have so many words, so many sentences. The important thing about InterCorp is that it is the Czech is the most popular language in InterCorp, because every text must be in Czech and in some other language, at least one. And so for this text, we have 28 languages, but this is fiction, right? So in other genres, we can have more text, more languages for one text. In most languages, it is a mix of translations and originals, and we have so many genres. Yeah, so fiction is kind of the best we can offer, because the other things are just more easily available online. Now you can see how unbalanced InterCorp is in the number of languages and also in the number of words. Now note the scale. Yeah, this is logarithmic scale. Yeah, so some languages have really very few words, and there are some Slavic languages win, of course, because there is Czech, and also in the number of languages covered. Yeah, and some of these language genera, these are not families, that would be Indo-European. So for genera, we have, of course, Slavic wins. And so for this research, we couldn't just take all. We had to make some choice. So we tried to pick those languages for which we have reasonable coverage of genres. And so these are the 17 languages that we have picked, three groups and one other group. And we have 4 textual genres: fiction, subtitles, legal proceedings, the Europarlament proceedings. And that's because, of course, the other languages do not have these resources from European Union, such as the Europal proceedings, and they just couldn't compete. And so these are the statistics, and you can see the subtitles win overall in all these counts, except number of texts, where European Parliament has many texts, like some of these MPs just don't talk too long, so the texts are not that long. But for sentences, of course, subtitles have the largest number of sentences, because, of course, in subtitles the sentences are short. Okay, now about these metrics of syntactic complexity, you've seen that already, and I just added this reference. Some of you might remember, and you will see why. Yeah, just a bit later. It's still 30 years, and it's not counted into these 47 metrics. So the metrics, some are like category ignorant. Yeah, so we count just words, and some of them count nouns or noun phrases, and some count clauses, finite, non-finite, altogether. Okay. And now the dimensions. So if you imagine the tree, so the tree has the width and depth, and the width dimension is covered by number of words. That's easy, and also number of words within some categories, and depth. So that's the level of embeddings within the tree. Yeah, and some of these measures are hard to classify along these two dimensions. So some of them are kind of in between. Yeah? So maximum NP depth, it's clearly the depth of the noun phrase, yeah? or the nominal group. Yeah? And also the tree depth is kind of very, very much depth oriented. But this is mean dependency distance. It's hard to say whether it's really length or depth, or width or depth. Okay, so this is Olga who likes this. There is Manning's law in universal dependencies, so that's something to justify a compromise between competing criteria. And so this is something similar for syntactic complexity metrics. So they should be implementable, reliably established, and you've heard that already. And now, what do we do with them in InterCorp? They are implemented as metadata. So metadata are author, title, date of origin, and such things. Now, we add these metrics for each sentence and also for each text as weighted averages for the individual sentences. So first, about the max NP depth. So that's easy, maximum number of embeddings in any NP. So that if you look at the sentence, so we search the deepest NP and note the number. So if you have a sentence that the child reads a book, so this NP has the NP depth 1, and we take it as in this sentence as the number for that. Length, that's also easy. We just count the number of words within that NP. And now the slightly tricky part is what counts as an NP in the UD annotation. Because yeah, you can have nouns, of course, pronouns, yeah, pronouns, and proper nouns as well. So we take all of them as a signal that this is an NP. Yeah, so whatever heads the NP and as some tree and has these categories. Now that's part of speech categories. So this counts as an NP. You may remember that in UD coordination is resolved as a kind of dependent. The second and other members of coordination the other conjuncts are treated as dependent. So we don't want this to spoil our calculation. So we treat every conjunct separately. We ignore punctuation. And another trick is you may remember that in universal dependencies, if you have a copula in a sentence, so the copula is treated as a function word, and the nominal predicate is the head may be of all the sentence or all the clause. So we do not want subject, and we don't want maybe some adverbials to be included in that calculations for the noun phrase. So we just ignore copula and adverbials and subject. Okay. For clauses, so similar to max NP depth, we have max tree depth. So that's for clauses, not just for the whole tree. And we count those categories that have these functions, or it's dependency relations in universal dependencies. So you may notice that it's not just finite clauses, but also non-finite clauses, and that's what we do. Yeah. So if we have a sentence such as "My dog also likes eating sausage," so likes eating, this is annotated as xcomp in UD, and we note that this is a verbal category, and the max tree depth in this sentence is 1. And sentence length is just number of words, ignoring punctuation. Now, you may think that number of words is a very robust measure, and that we can compare it across languages. But look at this. Yeah. So this is the same sentence translated into well, there's no origin. Oh, there is this original sentence. This is of course from The Little Prince, and we have various translations. Now, the extreme is Czech. One extreme is Czech, just 5 words, and the other extreme is Japanese. And you may think, oh, 17 words? No, actually, it's tokens. Yeah, and it's the way of tokenization that does this. Yeah, and in the Japanese annotation of universal dependencies, you tokenize even function words. Yeah, so the blue ones are all function words, and you can see how large the tree looks like. Yeah, whereas in Czech you would have just five words, but in Japanese you have those 17. Because the grammatical words are separate tokens. Okay, now subordination ratio. You've heard already about subordination ratio. Yeah, so that's this explanation, and this is just an example. Garfield likes eating and grunts. There can probably be no simpler sentence illustrating subordination ratio than this. Yeah, so you have two T units, and this is the results. Yeah. Now, mean dependency distance. Yeah, that's a bit more sophisticated measure, because you start from labeling all words in the sentence by the number. That's the order number of the token or the word within the sentence, and also about its head. Yeah, so my depends on dog depends on like, and so on. Yeah? And then you just subtract these two numbers and get the distance in word boundaries between the two, between the word and its head. So dog has to travel 2 word boundaries to get to his head. Yeah, which is like, well, like has 0 as its head. And the mean, and you calculate the mean of all these red numbers, and you ignore punctuation, and you get this number. Now, you may think, oh, that may be nice for things such as non-projectivity and such things, but notice that this measure also counts this dependency as being slightly more difficult or longer than the others, and that's because we have just also, but also depends on verb, and there is no non-projectivity. And now comes the picture from Holland and others, calling 97, I think, 98, Montreal. So they do not bother about these things. They bother about non-projectivity, and so they count only when the non-projectivity strikes. Yeah, and to show you that they really do it, so there is something like za dnešní krize. So these two are dependent on krize. And these pairs are the same, but they do not count anything, any number that makes the sentence harder to process or has a larger complexity. Now, this is just an illustration of a sentence, and the little prince went away thinking of his flower, and you see the numbers computed for this sentence, and I told you that for the whole text we do averages for all sentences within that text, and you know, this is really a quite simple text in terms of complexity. So these numbers are fairly low compared to other texts. You can have these figures for all text, for every text in InterCorp, but you can also look at this table that's not in the search engine, but it's in the documentation on the Wikipedia, on the DocuWiki for InterCorp, and you see for each language, for each genre, you see those measures, and they are calculated from as an average for all texts that are included in that category. Okay, then a little bit about the method. Yeah, so to answer the research questions, we have each sentence in the subcorpus, not only in the corpus, but in the subcorpus, associated with the complexity metrics and the metadata, yeah, so that we would know what is what. We take texts. We do not deal with sentences. Yeah, we do it for text. All the subsequent analyses. They are aggregated as the means, averages, but also as standard deviations. Yeah, so it's not completely naive. And when we need the same amount of data for some tasks, so we have to have some way how to pick the texts. So we create samples that are based on the smallest group, yeah, so the combination of genre and language, and of course the other groups must have the same number of texts, so that it will be comparable. And that means that for some statistics, such as fiction, so Latvian, of course, dictates what all the other languages should have. And the other important thing is that the sample texts compared across languages, they are not really parallel versions of the same text, yeah, because we do not have the same text in all those languages. Yeah, they are just comparable, they are not parallel. Over. Yeah.
So let's move on to some results. Well, so the result part will be organized in two big parts according to the two research questions. So first, correlation of metrics. So the first research question, how do syntactic complexity metrics correlate with each other? So you remember the 6 syntactic complexity metrics. So the correlation between them. So if I count it well, it's 15 different combinations of syntactic complexity metrics. So MDD, subordination ratio, MDD, maximum T-depth, and so on. And how do these correlation patterns differ across languages and across genres? Well, first of all, so the correlations were calculated as Pearson correlation coefficients for each pair of the 6 metrics, so 15 combinations, as I have already said, both for genre and for languages. And the values of each matrix are the result of averaging the corresponding sentence level values. And it's important that the results were visualized using 2 different methods. First of all, hierarchical clustering tree. So this will be the most general visualization method. And then heat maps, so for a more detailed presentation, going into the details about languages and genres. So first of all, the most general visualization using the hierarchical clustering tree of the syntactic complexity matrix based on correlation patterns. So as you know, so in hierarchical clustering tree, so the lower the elements are clustered together, the stronger the relationship between them. And you can see that the two clausal metrics, so Sasha has introduced, so they correlate really very low, so at the lowest distance, which suggests a very strong relationship, which means so the higher the subordination ratio, the higher maximum tree depth, the probability of the maximum tree depth. Naturally, you can have sentences with high subordination ratio and low maximum tree depths, but probably more likely, so they will correlate really very strongly. The two NP metrics correlate at a higher distance, but still very low, so which suggests again a very strong relationship. Again, this is understandable. So the longer the NP, the higher the probability of complex, so in terms of hierarchical structuring. The two remaining metrics, so MDD, so mean dependency distance, and sentence length, they correlate they merge at a higher level, but still there is a relationship, very probably based on a shared property, which is the relation to the word count. So both these metrics are based on word count. Again, as just Sasha showed also on the paper, so the longer the sentence, the higher the probability of higher MDD. And again, we can also see that these two metrics, so MDD and sentence length, and the two NP metrics, they correlate also, they merge also at the very high level, but there is still a relationship between them, very probably also based on the word count. So the two clausal metrics here, they are the most specific, since they are based on mostly not on word count, but on clausal complexity of the sentence. So they are the most specific. Yes, reminder of MDD, how it works, but you remember it. Well, so we can say, so what's the result of this first visualization? It is that, in syntactic complexity research, it's necessary to consider both dimensions of syntactic complexity, which means not only width or length, for example, in terms of sentence length and so on, or NP length, but also the depth, so the hierarchical organization of NP or of a sentence. But also, it's necessary to take into consideration the structural distinctions between the clausal metrics and the phrasal metrics. So it's really multidimensional. It's really complex. The complexity is complex. We are now moving to a more detailed visualization of correlations, which will be correlation patterns of syntactic complexity metric across all languages, across languages and genres, so a detailed one. This one was just so all together for all genres and all languages together, but this will be very detailed, so prepare yourself. It's like this. Well, what you can see, it's a heat map, so it's one heat map, but divided so in two parts. And you can see here, so the 15 combinations of syntactic complexity metrics, so maximum, so MDD, maximum NP depth, and so on. So the 15 combinations, and so the correlations in combinations of language and genre. So for example, Portuguese fiction, Swedish Europarl, and so on. And you have the numbers of correlations here. As you know, the darker the color, the higher the correlation. And you can see that, first of all, so this heat map confirms so observations made in the hierarchical clustering tree. So here you can see the dark columns, so the high correlation of the two NP metrics, and also the high correlation of the two, this is not visible, of the two clausal metrics. So this is really across all languages and all genres. It's very high, so above 0.9 across all languages and genres. What's also interesting that MDD, by contrast, shows the lowest correlations with other metrics, which suggests that this is the most distinctive, the most specific metric. except with sentence length. So you can see that MDD correlates with sentence length, but with other metrics, so not so much. So this is really a very specific metric. But this is, so for the moment, this is for all genres and all languages together. But what's important that this heat map also shows important intralinguistic differences between the different genres. So there are genre specifics. First of all, in Aki, it shows the highest correlations from all the 4 genres. If you imagine it, so we have 15 combinations of metric pairs and 17 languages. So 15 multiplied by 17, it's 255. So 255 combinations of language and metric pair. And from these 255 combinations, Aki shows the highest correlation metrics in 218 combinations, which means more than 85%, which suggests Aki is really very homogeneous as genre across all languages and all genres. This may be due to various factors. First of all, legal texts are very conservative and very strict, so in terms of their syntactic structure, but also there is a specifics of acquis communautaire because there are only 2 source languages, English or French. Now it's mostly English, so there may be also interference from source language. And there is also another restriction, which is translators in European Union, they are encouraged to respect sentence length of the source text. So this may enhance the correlations across languages as well. The second most homogeneous genre is surprisingly subtitles, maybe surprisingly, but it is also, it shows also very high correlations in all metrics, and it even outperforms acquis in clausal metrics and also in the NP metrics. So it's really very homogeneous, which is interesting because these two genres, they show the highest correlations, but in the real values of syntactic complexity metrics, they are on the opposite sides. So subtitles, the shortest sentences, acquis, the longest sentences. And so in terms of NP depth and so on, they are on the opposite side, but there are strong correlations showing high homogeneity of the genre. And move on, the remaining 2 genres show higher, so lower correlations across genres and across languages, Europarl and fiction. For example, in fiction, so in 36%, the fiction shows the lowest correlations, so from all the combinations, which may be due to 2 different factors. First of all, for example, as shown in Embedding and Embedding 22, in fact, fiction is a composition of 2 completely different discourses, narrative and direct speech, which are completely different in terms of syntactic complexity and other linguistic features as well. And another factor is stylistic variation. In fact, in fiction, the authors often push the limits of the language, so to extreme points. So Faulkner, Proust, Camus, and others. So there is a high stylistic variation inside, so the genre, and therefore there are lowest correlations. And this is why in cross-linguistic studies based on fiction, we should take explicitly into account also for style of different texts as additional factor. So now we move on to the second research question, and this will be Sasha again.
So this will be about how the models are good at predicting genre and language depending on the metrics. And we asked which metrics better predict genre and which better predict language. So how do we find the best predictors? We use random forest classification models. We use feature importance analysis to identify the most informative features, where the features are metrics and also their dispersion within texts, standard deviations. We have two sets of classifiers trained for one for genres, one for languages. For each, we save those models, confusion matrices, accuracy, and F1 scores, and feature importance comparisons. I will show just not everything, but what's hopefully something most important. Yeah, we split the data into this this test part and training part, and they are all the visualization are at this address where you can find all of the stuff. Now, the important thing is that the goal is not to examine how do metrics behave, is to examine how do metrics behave, and not to make real predictions. Yeah, so we are not such fools to aspire for real prediction based on complexity metrics, but we are just interested in how the metrics behave. Yeah, and that's why we do it. So this is the result of applying the models to classify genres in those languages. And you can see that we are fairly successful. So and also the confidence intervals are well, they differ, but they are not that bad. Now, why is this? Well, we have only 4 genres in the corpus, and we have those 17 languages. And so, but the result is that really the complexity metrics still are strong indicators for genre classification. So, and so the conclusion is that the genres really differ in those complexity metrics. Yeah? So this can prove something. Yeah, so this result, and this is important for corpus-based research. So it may not be the good idea to lump all genres together for some research because they really differ. Now this is a completely different picture. Yeah, this is for language classification across genres. So there are differences, but overall you see that the success is quite low. Although the dispersion is very small in some cases. And subtitles and ACI are much better than fiction and Europal. So why is this? Well, of course, we have 17 languages to differ, yeah, in this task, and these are these 4 genres. As Olga said, we have this high internal variation in fiction, yeah, these contrasts. So that's probably explains the low success here. And in Europal, we have many different speakers contributing short texts. Yeah, so and we are really not good at making decisions if we don't have enough data. Yeah, so this is the reason for even lower success here. And the more success here, it's because we have more cohesions in ACI and subtitles, and you've seen it in those in those heat maps, the correlations, and it's also due to external restrictions. You've heard it already. This is just the same, but it's by language. Yeah, so this is not accuracy. This is F1 score for a change of language classification across genres. Yeah, so for each language you have these 4 genres, and you see that some of those genres are really much better predictable than others. And so the pattern is confirmed. ACI and subtitles win overall. But yet, and this is interesting, and you can only see it here. So there are differences between languages. You know, you see it. Yeah? So, for example, Dutch fares much better in fiction and Europarl, and Dutch is actually better than any Czech or Slovak genre. Yeah? And of course, Czech is probably very easy to confuse with Slovak and maybe with some other Slavic languages. It's interesting that the Dutch is not so easy to confuse with German, maybe, or some German language. Okay, but more about this in a second. Oh.
Okay, thank you. Well, in fact, yes, Dutch is confused with German, and this is what we'll show in confusion matrices for genre and language classification. As you know, so confusion matrices show, so to what extent the true label, so this is the y axis, so matches the label of the predicted by the model. You can see that here, so it's confusion matrix for Czech. I think, yeah, for Czech. So it is for genre classification. So how good we are in predicting a genre. So you can see that. So it's very reliable, as Sasha has already explained. So for genre we are very good. So it's easy. So the misclassifications are really rare, which suggests that syntactic complexity metrics, as Sasha has already said, so are important features discriminating between genres. There are some exceptions, misclassifications between fiction and Europarl. For example, in French, here you can see that Europarl is so this is the true labels. It was Europarl, but it was classified as fiction. I don't know what the French deputy said there, but yes, it was classified as fiction. But overall, you can see that this is very reliable, so across all languages. For language classification, however, the picture is completely different. And there are misclassifications. Some of these misclassifications are so aligned with a language genera, as Sasha has already mentioned. For example, here we have a nice Romance cluster. Here, this is the Dutch and German. I think that German and Dutch wouldn't be happy to hear it. But yes, they are very often misclassified as one another. And there is a not so clear Slavic cluster, so in the down right corner. However, for example, in Czech and Slovak, as Sasha already has said, so they are very often misclassified, for example, in subtitles, but also I think in fiction. So in subtitles, very clear. So Czech and Slovak, so they're often misclassified, one as another, which confirms so the structure of proximities. In fact, I find these heat maps very interesting from a linguistic point of view because they reveal the similarities between the languages in terms of syntactic complexity. And what's more interesting, so for misclassification within language genera, for example, the Italian translation of Kundera's novel The Joke was classified in fiction as French. So this is one of the examples. Or for example, again, the Italian translation of Jane Austen's novel Emma was again classified as French. So there are similarities between these two languages. But what's more interesting is our misclassification across the different linguistic genera. For example, English is often misclassified as Romance, mostly as French, but also as Spanish. For example, I think that Vargas Llosa's novel La Conversación en la Catedral in Spanish was misclassified as English novel. So there is one of the examples. This, in fact, confirms other observations made by, for example, Sedeniemi et al. For word properties. So in classifications based on word properties, English was often classified as Romance. And there are also, yeah, okay, it was Italian. What's also interesting, these are In fact, there are enigmas also, so going across different genera. For example, Danish text fiction, for example, were surprisingly classified as Bulgarian. It's, for example, Tolkien or one novel by Rowling or Lewis Carroll's Alice in Wonderland. So in Danish, were classified as Bulgarian. I don't know why, but I think that this, in fact, indicates that it will be necessary to go deeper in the specific linguistic features underlying these misclassifications and to show, so what are the similarities between these languages in terms of syntactic complexity, and also which syntactic metrics, specific syntactic metrics, lie behind these misclassifications. And this is something Sasha will show you more in detail in the last part, so the feature importance analysis.
Okay, this won't be long. We were trying to find out which features are important for the classification. Yeah? And we take both average and dispersion in the statistics for the texts. Now, for genre classification, it seems that NP metrics rank highest. Yeah? Max NP depth mean, max NP length mean. Yeah? And the sentence length and max tree depth are below. Now, standard deviation, the first is only the fifth one. So this is still maybe important, but not that much. Yeah, so it shows that the relevance of NP metrics for interlingual variation in genre is really important. And there is this similar observation made, Doug Biber. He was concerned in the contrast between spoken and written language. And he noticed also that the NP metrics are important for that. Yeah, so written language uses more elaborate NPs than spoken language. Now, for language classification, the picture is very different. Yeah? Note that language classification was not a big success, but when it was able to yield some results. So MDD was the main cause of the success. Yeah, but not only the mean, but also the standard deviation. Yeah, it ranked second. And then only came the NP measures and sentence length. And so the question is if MDD is really something more robust, that it works across languages, and also maybe MDD is so good at differentiating between the languages because it is least correlated with the other metrics. So these other factors that are responsible for these genre differences do not play such a strong role.
Yeah. So which leads us directly to conclusions and hopefully discussion, the most important part of the presentation. Well, to sum up, so in this presentation, in this talk, we wanted to investigate the interplay between three ingredients, so syntactic complexity metrics, language, and textual genres. And we addressed two research questions. So how syntactic complexity metrics correlate across languages and genres, and which metrics are more predictive of genre or of language. The results showed substantial variation in both languages and in genres. So this is important to take into consideration the three of them. And it was across the three methods we applied, so correlation patterns, classification accuracy, and feature importance. So that was, you could see that we were keeping saying, we have already said this. So the results really point to the same direction. As for the correlation analysis, so the first part, so there are some stable patterns across all languages and all genres. First of all, there are strong correlations between the two clausal metrics, so subordination ratio and maximum tree depth, and between the two NP metrics, so NP depth and NP length, which means that the width and the length of the sentence are strongly related, which is understandable. However, MDD showed the weakest correlations with other metrics, with the exception of sentence length, which suggests that this is the most discriminative and specific metrics, which was confirmed in feature importance analysis, where it was really the most relevant metric for language identification. And I think also that there is an important methodological outcome, and this is the recent development in corpus linguistics, that in corpus linguistic studies, we have to take into consideration not only the mean values, but also the dispersion. It's important to take into consideration both. And also it has been shown that clausal and phrasal metrics, so they cover different dimensions of syntactic complexity. So if we don't take into consideration one, so we are blind of one eye, in fact, in this case. However, there were some important patterns, genre-specific. So there are intralinguistic differences within the languages in syntactic complexity. First of all, ACI and subtitles showed the highest correlation across metrics and languages, which indicates great homogeneity of these genres. And fiction and Europarl, so by contrast, exhibited the lowest correlations, which suggests also the higher internal heterogeneity. I think that in Europol, the average length of the speech, of the text of one NP was 200 words. So if you have a large number of very short texts, so it's probable that there is very high variability in syntactic complexity. So the role of genre in syntactic complexity research is really very important, and it's also cross-linguistically relevant. Sasha.
I just have one thing. Yeah, maybe. Yeah, so as you've seen, the metrics were very good at differentiating genres within languages, but much worse for languages. And especially in fiction and Europarl, that may be due to internal variability, and you've seen the similar results in correlations. So for genre, NP metrics were most salient, you've seen it. For language classification, mean dependency distance, which is largely irrelevant for genre, emerged as the most important factor. And also because it's least correlated with other metrics, except with sentence length, in the same classification, in language classification, both mean and standard values of MDD were relevant. And so it seems that mean and dispersion really is important to be combined in future research. Well, speaking about MDD, and this may be a topic for the future, really our expectation was that MDD would also show differences in languages in terms of how many discontinuous structures it would show, decent projectivity issues, but MDD is actually kind of blind towards this, yeah. And for that we might consider Holland et others, 1998. Okay. Now the confusion matrices, they revealed possible proximity in syntactic complexity within the language families or genera, as we have them there, and also across. Yeah, English is closer to Romance languages, maybe than to German, surprisingly. and especially for French, we might do some more research in this direction, finding out how these correlations come up. Okay.
The, the last switch, I promise. So this is obviously just a beginning. So what is ahead? For example, we need really to investigate more in detail the specific linguistic features of different languages underlying the differences we have observed. So differences in syntactic complexity and also the specific metrics, so underlying these differences. But we also have to analyze the potential impact of translation direction and interference of source language in this point, and also, which would be really very interesting, to investigate the differences in syntactic complexity within one language between translated and non-translated text, so whether there is a tendency to simplification, normalization, and so on. It will be also, so InterCorp will allow us also for investigating the interplay between syntactic complexity and lexical diversity, because there are also, so we haven't mentioned this, but there are also two lexical diversity metrics, so for each sentence and for each text, thanks to Jiří Melička, so we have mentioned at the beginning of the presentation. And in the new version of InterCorp, it will also be easier to include a broader range of non-Indo-European languages. But in all these domains of research, it will be necessary to take into account both the impact of both language and genre. So thank you for your attention, and thanks to Bohumil Šimčík and Martin Vavřín for the syntactic complexity metrics in InterCorp. Thank you.
Well, thank you very much for a most interesting paper and investigation, which is, one can imagine how to say that, difficult or time-consuming it was to come to this result. Now, space for questions.
So thanks for the presentation. I have one question and two comments, but please stop me if I'm too long. The question is how actually the classification works. So you convert each text into, you have about 15 metrics, am I right?
No, 6 metrics.
6 metrics,
okay. But 15 combinations.
You convert to 6 real numbers, and for each metric there is the mean and standard deviation, so actually 12 numbers for each text, and that's the only input for the classifier?
No, for each text, yeah, you were right.
For each
you have 12 numbers,
yes,
for each text, and that's the only input to the classifier. Yes, thanks. So one comment is that I actually find it very inspiring, and maybe for all of us, whatever research we do, even if it's not the syntactic complexity, but I'm thinking, for example, for coreference resolution, we may convert the corpus, let's say each text, into some numbers where we know that we are actually simplifying, that it's not preserving the nature of the text, it's just 12 numbers, but maybe the length of the coreference link or how many often they cross the sentence boundaries, whatever discourse and so on. And then try to classify either the language or the genre, or actually there could be many other things to classify, and have such nice visualizations which will tell us which of these metrics have some interplay. So that's the very positive and inspirational comment. I'm thankful for this. One comment is more critical. We should be careful to interpret it that, okay, these metrics actually predict the genre or something like that. I'm afraid that if you take also the standard deviation or variance into account, that even if you did some like nonsense sampling into pseudo genres, where actually you would have, let's say, mixture of 2 genres, but actually this will make the high variance because there will be some short sentences, some long sentences. So even if there would be not really much in common, we will still, I'm quite sure we will be able to predict these with very high accuracy if there are only 4 genres or only 17 languages. So the interpretation needs to be careful, but still it can give us some insights into this. And one last comment for inspiration is we could, or you could maybe do just instead of these 12 numbers, convert it to maybe the delexicalized dependency trees where you keep just the dependency label and the shape of the tree, but not the lemmas and so on, or even delete the dependency labels, just keep the shape of the tree. This would definitely boost the accuracies, but maybe then you can find some patterns which are typical for a given language, that in French you can have the adjective both on the left and right side of the nouns and so on, but maybe there will be some patterns which we are not aware of that are predictive of the genre or of the language. So sorry for being long. Next question.
Stasha, maybe you want to react. No, just for the trees, our problem in this would be that we, in fact, we work not with sentences, but with averages for texts. So this is really a good idea. So as for methodology, but if we work with texts, I don't see how we would proceed. And maybe you understand it well.
Yeah. Well.
But thank you very much for
the comment. Thank you. About there was a discussion at the beginning of this research whether we would really just lump all the sentences within the text together and get these averages, or whether we would just leave the sentences as they are and maybe use them with metadata related to the text. Yeah, so that would somehow preserve the distinctions between genres and languages and things, but somehow the argument that we want to preserve the text in the research as some entity that is more important than some breadth of all possible sentences that we might get from all the data. So this one, this idea that we really want to preserve the text as some unit, and in fiction it does make sense because the text can be very, very different. Yeah, and so of course you can do, probably you could do it even with when you take individual sentences, right? But then the proportion of sentences that we might have from some very short text, such as Little Prince, might really be so small that you wouldn't learn much from. Yes, so we would have to keep the proportions, relative to the text, and issues like that, made us think twice. Yeah, about prediction, of course. Yeah, I didn't say it probably, strong enough, or I should have said it. We were definitely not after predicting anything. We were just trying to find out how. What these measures do for us, what meaning they have. Yeah. So, and that was a way how to test it. And about delexicalizing. So I think isn't it more to do with parsing more than with what we do? Because we already get parses, like with and we don't deal at all with lexemes or with so I think we wouldn't get any more profit from that, or maybe I didn't understand
I will leave most of it for the discussion afterwards, just to explain this. Your scores were delexicalized. You don't need the lemmas for the 12 numbers you have. I was just saying that we could have even more features than 12, and these still can come from the delexicalized tree. So, but it could be more rich than your 12 numbers. Okay. So we can use also the shape of the tree, which you use only in the NDD. This is the only metric. Well, there are a few metrics which use the parsing, but somehow very, very simplified. So we can do something in between.
Thank you for presentation. I have two questions. The first is more concrete. When you spoke about stronger reliability and correlations for ACIs and for subtitles, you mentioned more cohesion possible. What could it mean actually? Is it so really for these genres more cohesion is possible? So this was the first question. And the second is more abstract. I'm a little bit unsure. So I'm a little bit confused by the word complexity in this whole analysis. So when you say that something, is it real syntactic complexity? So is it complex also? Does some objective syntactic complexity exist? So is it? So for example, when you use depth in Czech using subordinate nominal constructions, like is it something much more complex understood by a Czech speaker than when you use them in English? Is it somehow concerned?
Okay, yeah. Thank you for your question. I'll start. So Sasha needs the micro, I don't. Oops, tension. No, it was it. Yeah, okay, about the, I don't need it.
You need it.
I don't need it.
No.
Okay, I do need it. Okay, thank you. Yeah, okay, thank you. So about the cohesion, so about the ACI and subtitles, fine. So I think I'm not sure I've mentioned cohesion. I have mentioned homogeneity. So in terms of syntactic complexity. So if all the metrics correlate really, so there is very few internal variation probably, so within the genre. So it's not really cohesion, but I would call it really homogeneity. So the texts across all languages are more alike in ACI and in subtitles, whereas in Europarl and in fiction, so there is more internal variation. So I wouldn't call it really cohesion, yeah, in this, yeah. Yeah, sorry. Yeah. No, it was no. It wasn't. And as for the perception of complexity by language speakers and hearers, this is in fact so another approach to linguistic complexity. So this is this relative or subjective cognitive syntactic complexity, and we don't this in our research. So we don't deal with humans, thanks God. But only with the text. But this is also, I think, that would be an interesting complement of the research. So to have this absolute usage-based text complexity, and to complement it with an experimental research, so into this subjective cognitive complexity. So how do they correlate? So whether it's also what we perceive as complex. So for example, in Czech or in English and so on, whether it is perceived as complex also by the language speakers or readers and so on. Yeah, I don't know whether you want.
Yeah, I was also wondering if maybe in English those ing participles are comparable to Czech relative clauses or adverbial clauses or even transgressives. You know, it's and you know, all these measures are very formal, and how to count into this or calculate this factor of how often it's used in that language. Maybe speakers don't even realize that it's more complex than some other construction in some other language which is on the surface like very easy, yeah, but still quite rare. Yeah, so maybe these transgressives. would be a case in point. Yeah. So, well, okay, that's just my comment.
Mhm.
Translations in the original.
Yeah, okay. Yeah.
I think it could be also interested to compare this kind of complexity in originals and translated text, so that when translated, we could stay more complex for our own language. Actually,
Yes.
well, thank you for.
Yeah. Yeah, we have in fact, so there is literature on this also, and this is something I was, so when we were designing, so the implementation of syntactic complexity metrics in InterCorp, this was my dream, yeah, to have the possibility to compare originals and translations as to the syntactic complexity, and so we have also beginnings, so some beginnings of the results in with this respect, but it would be also interesting. This is something I mentioned in the outlook. But for example, in confusion matrices, the Portuguese and Italian translation of Hemingway's *The Old Man and the Sea* were classified as English. So the Italian and Portuguese translation, so which means that the translators respected so well the style of the original that the resulting text was classified as English. So, and there are there are other misclassifications, and it would be interesting to look into, in fact, so this would be sentence length, so subordination ratio, some other things. So, so which are the metrics behind these classifications? So it's, yeah, this is fascinating. Yeah. So what happens, so how translator, in fact, at the same time respects the source language, but so he puts the text in the target language. Yeah, this is interesting, definitely.